members of the respected panel. Today, we, the members of Group 43, are here to present our project, Smart and Safe Driving Assistant. We'll begin with our introductions.
Myself, Saksham Chopra of branch ENC.
Myself, Saksham Jain from branch ENC.
Myself, Varun Joshi from branch ENC.
Myself, Vaibhav Chawla from branch ENC.
Myself, Abhinav from ENC branch.
This project is under the supervision of Dr. Neeru Jindal ma'am and Dr. Shubhra Jain. India is an emerging superpower in this modern world. We have the largest democracy with a whopping population of over 139 crores. However, our country has a tarnished image when it comes to road safety. It gives us immense pain while mentioning that 11% of total deaths due to road accidents come from India. Our team has carefully analyzed the issue and we have narrowed our problems down to two main issues. Firstly, the use of phones during traveling has made an increase in accidents up to 4 times. Also, large number of accidents take place due to the fact that the tail lights of the two-wheelers are sometimes below the level of vision of majority cars and four-wheelers such as the SUVs and the heavy motor vehicles. It is our responsibility now to accept the need of safe riding on two-wheelers and create the awareness about the same. Our team introduces Smart and Safe Driving Assistant that focuses on the safety of the two-wheeler riders by preventing accidents and saving lives. Major cause of accidents includes faulty and low-level tail lights and indicators which are generally not visible to the bigger vehicles. A helmet is a type of a protective headgear used by the rider which makes two-wheeler riding safer than before. This system is implemented by using hardware and software technologies like Arduino and app development. The helmet includes tail light, indicators, and a call declining app to ensure safe driving.
The main component of our project is Arduino Uno. It is used in detection of brakes with the help of accelerometer, which is known as MPU6050. It is a MEMS inertial sensor that contains 3-axis gyroscope, 3-axis accelerometer, and works on I2C protocol. In this slide, we show the circuit diagram and the open source code. This code reads the values from the MPU6050 sensor and displays the result in the serial monitor. The only problem is the values from the sensor are unnormalized. As we know, the value of small g is 9.8 meter per second square, so the sensor lying flat should display 9.8 meter per second square. So in this code we have made some changes and normalized these values, and we can clearly see that the value on the z-axis is close to 9.8 meter per second square. Now let's plot these values on the serial plotter. We can clearly see that one value is close to 9.8 meter per second square, and as we change the orientation, another axis value goes to 9.8 meter per second square. The value keeps on changing as we change the orientation of the sensor. Now the above results are used to deploy the braking system. The tail light on the helmet will glow when the bike will deaccelerate. The previous 10 and 50 values measured by the accelerometer after normalization are collected to be analyzed. The average of these values is taken and saved as two individual sets. The difference between these two sets value is calculated, and the difference is greater than a particular threshold. In this case, that is 1 meter per second square, tail light is activated. Now we can see if the difference between these two values is greater than 1 meter per second square, then there is a glow indication on the serial monitor which depicts the glow of LED lights on our helmet.
After the braking system comes the tilt and indication system. Our mobile would be fixed on the two-wheeler's body using a stand. We will obtain tilt values from our app using accelerometer on our mobile. Then we have checked if the inclination angle is towards left or right and encoded that as low and high. Then this high or low signal is sent to our Arduino by pairing it with our mobile using HC05 Bluetooth sensor. According to the received signals, the indicator will turn on. The formula used to calculate tilt orientation, that is roll and pitch, are as shown. Here is the video demonstration of how the tilt indication works. The output on the serial monitor gives the roll and pitch values to measure the tilt. Next, in processing development environment, we can see the 3D visualization of the sensor. The 3D visualization tilts the same according to the sensor and gives the desired output in terms of roll and pitch. Now comes the app development part. So our app uses the mobile's inbuilt accelerometer to measure the tilt. Our app acts as an alternative for the second accelerometer on two-wheelers. Alongside this, some advantages includes noise reduction as only 2 values are transmitted, use of only one Arduino board, economically feasible and better and more control over data generated for future purpose. Here is the sample screenshot of our app which displays values we need like user accelerometer. Here is the sample video of our application which shows the accelerometer values according to tilt of our device. These values will be used for the indicator to glow.
Our team has demonstrated the project using two videos. Firstly, without our safety gear, the rider can be seen driving his Activa and the car cannot properly see the tail lights when he brakes. So, collision occurs. And this is right now a subcompact car. So, the problems will definitely arise in case of SUVs and heavy vehicles. Through the second video, it is demonstrated that our safety gear attached on the helmet of the two-wheeler rider has enhanced his safety. Though the car is driving close, but the driver of the car can clearly see the lights go on when the rider of the two-wheeler decelerates. This prevents the collision and thus ensures the road safety.
So this was our whole project. Our group would like to conclude that our project aims to enhance safety in efficient and economical manner. Our project contains minimum requirements and maximum productivity at the root cause of the problem addressed through us for the common benefit. There could be some future scope to our project which may include addition of alcohol sensors or GPS sensor. Also, if our app could save some emergency numbers to which an accident notification could be sent along with location. But we have tried to keep our system as compact and precise as possible with less chances of failure. We have chosen a blend of hardware and software that gets the job done and at the same time does not make the functionality too complex and large.